Hello, good morning to all. Myself Binaranjan Patnaik. Today we are going to discuss about the processor system of computer system architecture. So in your processor system, these are the following articles we are going to be cover. First is your register files, complete instruction execution, fetch, decode, execution, and hardware control and microprogram control. So before going to the discussion about the processor system, first is your what are the registers are used in the CPU or why the registers are used in the CPU. Now registers are temporary storage location inside the CPU that hold data and address. Next is the register file is the component that contains all the general purpose registers of the microprocessor. A few CPU or central processing unit also place special registers such as the PC or program counter and the status registers in the register file. When designing a CPU, some people distinguish between architectural features and implementation details. So architectural features are the programmer visible parts. If someone marks a new system where any of these parts are different from the old CPU, then suddenly all the old software won't work on the new CPU. Again, the implementation details are the parts that, although we put even more time and effort into getting them to work, one can make a new system that has a different way of implementing them and still keep software compatibility. Some programs may run a little faster, other programs may run a little slower, but they all produce the same results as on the earlier machines. Next is your register files. A simple register file is a set of registers and a decoder, and the register file requires an address and a data point. So this is a simple register block diagram. This is the address, left at the address, your data, and the decoding enabling and enable the decode process, and then the data is really out. So decode means that now whatever the instruction placed or resides within the register, it is in the coding form, so it should be decoded before read the data. However, the simple register file is not useful in a modern processor design because there are some occasions when we do not want to write a new value to a register. Also, we typically want to read two values at once and write one value back in a single cycle. That means it is a simple register files, and this type of systems is not used in nowadays because here when you writing some, suppose here the example, some occasion where we do not want to write a new value to a register and typically want to read two values at once and write one value back in single cycle. So let's discuss with an example. Suppose here consider the following equation C equal to A plus B. Here A plus A and B, the two data which will want to read at a time, and after the manipulation or after the completion of the execution, the output will store against the C. So to perform this operation, we want to read two values from the register file A and B, and also have one result that we want to write back to the register file when the operation has completed. So for cases where you do not want to write any value to the register file, so in that case the simple register file is not working properly. So we add a control signal called read and write operation. When the control signal is high, the data is written to a register, and when the control signal is low, no new values are written. So here we are adding the read write operation, which is the register works as automatically. That means when the control signal in the high mode, that means the data is written, and when the control signal is low, no new values are written. But in the previous thing, that is not the possible. So this type of design now is adopted in the new generation computers. Here we are going to discuss about some registers which are surrounded by the, or you can say the processor is surrounded by a number of the registers. So first is your user accessible register. It can be read or written by machine instruction, user accessible registers. Next is your data registers. It can hold numeric data values such as integer, and in some architectures floating point values, as well as characters, small bit arrays and other data. So that is the data registers. It contains the value. Next is your address register. Now hold address and are used by instructions that indirectly access primary memory. This is the address registers hold the address and are used by instruction that indirectly access primary memory. So next is your general purpose register, which is known as the GPRS, can store both data and address, that they are combined data address register. In some architectures, the register file is unified so that the GPRS can store floating point numbers as well. So these general purpose registers are used for both the data and address, and they are combined data and address registers. And also in some architecture, the register file is unified so that the GPRS can store floating point numbers as well. Next register is your status register, which hold truth values often used to determine whether some instruction should or should not be executed. That means it contains the status of the instruction. That means truth values. Truth values means 1 and 0. This concept of the Boolean algebra. Determine whether some instruction should or should not be executed. That means according to the value, Boolean value of the instruction, that will decide that whether this instruction will to be executed in next or not. So that is the status register. Next is your floating point register. It stores floating point numbers in many architecture. Only it used to store the floating values. Floating values means decimal values, that is known the floating values. Next, constant register. It holds read-only values such as 0, 1 or pi. The constant register generally it holds the constant numbers like 0, 1 or pi. Next is your vector register. It holds data for vector processing done by SIMD instruction, single instruction, multiple data. It will be discussed in the chapter 7 when discuss the system architecture, computer system architecture. So vector that is known as SIMD, single instruction, multiple data. That means you are apply one instruction with multi numbers of data. That means this is the this status contained by the vector register. Next is your special purpose registers. Hold program state. They usually include the program counter, also called the instruction pointer, and the status register. That means it hold the state. They usually include the program counter, that means PC, also called the instruction pointer and the status register. Right, the instruction pointer, it is contains the pointer. That means it contains the address of another instruction. Right, what is the pointer? That is a variable which hold the address of another variable. So instruction pointer definitely it refers to address of the another instruction, and the status register, that means it contains the values of 0 and 1 through which you decide that which instruction is to be executed in next or not. Okay, thank you.